Alright guys, welcome to the last topic with momentum. We are going to be talking about elastic collisions. A lot of times the math with elastic collisions can be quite complicated in a physics class, but with conceptual physics we won't do it too much of that. So elastic collisions, similar to inelastic collisions, two objects collide and bounce off each other. However, this time both momentum and kinetic energy is conserved. So what does that mean? That means that if I had a ball and I dropped it, it'll hit the ground and the ball should come up to the same exact spot where I dropped it from. That would be an example of an elastic collision. There's nothing that is perfectly elastic in the world, but there are things that are very close. Okay, that being said, the equation is the same as inelastic collision. Momentum before the collision of both the objects is going to be equal to the momentum after the collision of both the objects, if there are two objects in this case. Okay, moving on. So a black billiard ball is moving with the speed of 5 meters per second and hits a blue billiard ball with the same mass that is at rest. After the collision, the billiard ball is at rest. What is the speed of the blue billiard ball afterwards, after collision? Okay, so if this is going 5 meters per second, and then after the collision this is going 0, we want to find the speed of this. Well, we know momentum is conserved and kinetic energy is conserved. So if this has a certain amount of momentum and that becomes 0, that means all the momentum of this needs to now be transferred to this ball right here. So that means it should be going 5 meters per second. Okay, because they both have the same amount of mass. That way momentum is conserved, kinetic energy is also conserved. Okay, moving on. A ball is dropped from 2 meters and bounces off the floor. If the ball has an elastic collision with the floor and the floor does not move, how high up does the ball come back up from the ground? We just kind of talked about this, but yeah. If it's 2 meters up, bounces up, the floor doesn't move, and it bounces back up, it should come all the way back up to the top, to the 2 meter mark. Because if kinetic energy is conserved, that means nothing was lost from this collision, and that means it should be able to come all the way back up to the same spot. Okay, no kinetic energy was lost in the collision. Okay, moving on. 1800 kilogram car is going 41.7 meters per second to the right, and rear ends 5500 kilogram truck going 27.8 meters per second. After the crash, the car is going 20.75 meters, 20.75 meters per second to the right. How fast is the truck going after the collision? Okay, let's write some things down. 1800, 41.7, and then we have a 5500 car going 27.8. Car is now going 20.75, and we want to know the velocity of the truck after. Okay, so we're going to kind of do the same thing we've always been doing. We could do it differently, but this is the most simple way. We could do it with kinetic energy, but that's a little bit more complicated. So we're going to do 1800 times 41.7 plus 5500 times 27.8. And then after the collision, we have the 1800 kilogram car going 20.75. And we have the truck, which is 5500, but we don't know what the speed or the velocity of the truck is after. So let's do some math. 1800 times 41.7 plus 5500 times 27.8. Okay, we get 227,960 is equal to 1800 times 20.75, and we get 37,350, plus 5500 velocity of the truck. So let's subtract 37,350 from both sides, and we get 227,960 minus 37,350 is equal to 190,610 is equal to 5,500 velocity of the truck. We'll divide both sides by 5,500. 5,500, and we get the truck is going 34.66 meters per second. And you could check that with the kinetic energy. You could find out what the total kinetic energy is before the collision, and then you could see what it is after collision, and it'll also be the same thing. Alright, so that's pretty much everything with the elastic collisions. For a little summary about the different kinds of collisions, please pause the video and look at this chart. But anyway, thank you guys so much for watching this. Next time we're going to be talking about something a bit more different with electricity. Thanks for watching, everyone. Bye.